Express 10 cos theta minus 3 sin theta in the form r cos theta plus alpha, where r is greater than 0 and alpha is greater than 0 and less than 90 degrees. Give the exact value of r and give the value of alpha in degrees to 2 decimal places. So the first thing we want to do is recall the identity that states that r cos theta plus alpha is identical to r cos theta cos alpha minus r sin theta sin alpha. That's just a general identity. So now what we can do with this is, as we're told in the question, that 10 cos theta minus 3 sin theta can be written in this form, that therefore 10 cos theta minus 3 sin theta can be written as equal to this, r cos theta cos alpha minus r sin theta sin alpha. So if we write that out as 10 cos theta minus 3 sin theta is equal to r cos theta cos alpha minus r sin theta sin alpha. What we can now do is compare the coefficients of sin theta and cos theta, and say that we can see on both sides that we have a term with a cos theta in it, and similarly we have a term with a sin theta on both sides, and we can equate these. So if we start off with cos theta, we can say that 10 cos theta is equal to r cos theta cos alpha. We can do the exact same thing for sin theta, so minus 3 sin theta is equal to minus r sin theta sin alpha. So if we go back to cos now, if we divide both sides by cos theta, because obviously that's on both sides, if we divide both sides by that, we get that r cos alpha is equal to 10. And if we do the exact same thing for this one here with sin theta, but this time if we divide through by minus sin theta, just because we have a minus on both sides, and it's easier to get rid of this and cancel that out. So we now get that r sin alpha is equal to 3. So now we have both of these, what we can do, and we can see why in a minute, is if we square both of these, so we get r squared, squaring both sides for both obviously, so r squared cos squared alpha is equal to 10 squared, which is 100, and r squared sin squared alpha is equal to 3 squared, which is 9. What we can now say is that r squared cos squared alpha plus r squared sin squared alpha is equal to 100 plus 9, because the two right-hand sides added up must be equal to the two left-hand sides added up. So this has to be true. And now what we can do on the left-hand side is if we take out a factor of r squared for the r squared cos squared alpha and the r squared sin squared alpha, we get the r squared and then bracket cos squared alpha plus sin squared alpha is equal to 109. Now, if we recall one of the trigonometric identities that states that cos squared alpha plus sin squared alpha is identical to 1, and we can see that here in this bracket we have exactly that. So we can now write this as r squared multiplied by 1, so just r squared, and this is still equal to 109. So just to get r, if we square root both sides, we get that r is equal to the square root of 109. So now what we can do, if we go back to our previous workings, and we call this equation here equation 1, so r cos alpha equals 10 is equation 1, and r sin alpha equals 3 is equation 2. If we do equation 2 divided by equation 1, we get r sin alpha, on the left-hand side, r sin alpha over r cos alpha is equal to 3 over 10. And then because these two r's cancel, and because we know that sine alpha over cos alpha is equal to tan alpha, we can say that tan alpha is equal to 3/10. And therefore, if we do the inverse of tan 3/10 in our calculator, we get that alpha is therefore equal to 16.70 degrees at 2 decimal places. So now we have everything we need to write our answer in the form that the question wanted, which was in this form over here, r cos theta plus alpha. So if we write it like this, we say that r, as we previously found, is root 109, and then cos of theta plus alpha, which we've just found to be 16.70 degrees, and that's our answer. And the 3 marks available for this question, our first mark comes from finding that r is equal to the square root of 109, and then we get a method mark for writing that tan of alpha is equal to 3/10, and our final mark comes from the fact that we find alpha is equal to 16.70, and therefore we can write it in this form that we've got over here. So that's kind of a joint mark for these two. The height above the ground, h meters, of a passenger on a Ferris wheel t minutes after the wheel starts turning is modelled by the equation h equals a minus 10 cos 80t degrees plus 3 sine 80t degrees, where a is a constant. Figure 3 shows the graph of h against t for 2 complete cycles of the wheel. Given that the initial height of the passenger above the ground is 1 metre, part BI is asking us to find a complete equation for the model. So the first thing we can do with the information we've been given is we can use the fact that we're told that the initial height is 1 metre. So initial height means when t is equal to 0. So we're saying that when t is 0, h is 1, and we can see on the graph here that therefore the h coordinate of this point is 1. So what we can do with this is we can substitute into the equation that we've been given over here that at t equals 0, h equals 1. So if we do substitute in h is 1, and then a minus 10 cos, and then 80t, where t is 0, 80 times 0 is just 0, and then plus 3 sine 0 again. Now if we simplify this a bit more, cos of 0 is equal to 1, that's just like a general fact. So minus 10 cos of 0 is minus 10 multiplied by 1, which is just minus 10. And sine of 0 is equal to 0. So 3 times 0 is 0, so we don't need to write anything else now. And then to get a value of a, if we just add 10 to both sides, we can find that a is equal to 11. So we can now substitute in a is 11 into the formula. And we now have that h is equal to 11 minus 10 cos 80t plus 3 sine 80t. Now, the mark scheme for this question actually has 2 examples of answers you could give. And one of them is stopping here. So you could give this as your answer and get the mark. But you can also go a bit further and use the answer to part A to kind of further this equation. So what we can do is, because in part A we were told that 10 cos theta minus 3 sine theta can be written as root 109 cos theta plus 16.70 degrees, you can see that this 10 cos theta minus 3 sine theta is very similar to what we have here. There's just a difference in the signs. So if we write what we have, which is minus 10 cos 80t plus 3 sine 80t, if we factorise out a minus sign, we're actually left with the exact same thing that we had for part A. The only difference being we've replaced theta with ATT. But this means that we can write this in exactly the same format as we did for part A, just replacing theta with ATT. So we can write this in this form, still keeping the minus sign on the outside though. So we're multiplying this whole thing by a -1, but that just makes negative root 109 cos, and then it's ATT instead of theta, plus 16.70 degrees. And we can write that as exactly the same because of what we found in part A. So therefore, we could have stopped here, but we can also write the equation as h equals, and then the 11, which just comes through. We never did anything to the 11. So 11 take away root 109 cos, and then ATT plus 16.70 degrees. So that's another way that we can write the equation of the model. So now for part II, we're asked to hence find the maximum height of the passenger above the ground. So if we look back up at this graph, the maximum height must be this point or this point, because these are the highest, the largest values of h that we have on the graph. And the way to find this is going back to our equation in h that we've just found. Because we have 11 take away, and then this root 109 cos ATT plus 16.70, because it's take away, that means that we want this to be as small as possible, or if possible, positive. In which case it would be as big as possible. And the way we do this is obviously by altering t, because that's the one, that's the variable that we can change. So if we take a look at cos of ATT plus 16.70 degrees, the largest value that cos can take is 1, and the smallest value that cos can take is -1. And we know this if we were to draw a rough sketch of a cos graph, where here is 1 and this is -1. And so we can see that the smallest value that cos can take is -1. And therefore, if we were trying to make this as small as possible, we would have to make it equal to -1. That's as small as we can get it. So if we therefore say that cos of ATT plus 16.70 degrees is equal to -1, and we substitute that in, we have h equals 11 minus root 109, but this is multiplied by -1, and therefore h is equal to 11 plus root 109. And now the 2 marks available for this question, because the marks come joint even though we have a part I and a part II, they are actually awarded in this instance. This isn't always the case, but for this question, that it's 1 mark for part I and 1 mark for part II. So the mark for part I comes from getting an answer, and as I said before, there are some multiple examples of the way you can write the equation, one being this way over here and another being here. So writing either of these would get you a mark. And our second mark comes from part II, and this comes from getting this answer. It's an answer mark for getting that h is equal to 11 plus root 109. So part C is now asking us to find the time taken to the nearest second for the passenger to reach the maximum height on the second cycle. So the second cycle, the maximum height would be this one here. So we want to find what this time is here. So the way we can do this is previously, in part B, we stated that at a maximum height, and it doesn't matter which one, so that will obviously include the second cycle, for a maximum height, cos of ATT plus 16.70 degrees must be equal to -1 to get our maximum height. And that will be no different for the maximum height on the second cycle. So if we were to solve this by taking the inverse cos of both sides, we get 80t plus 16.7, and then the inverse cos of -1 is 180 degrees. And for that, we know that this value of t so the first maximum, this is at 180 degrees. And we know it's the first one and not the second one because the calculator always gives us the first possible option, if that makes sense. So to find the next one, as a general rule for these kind of graphs, is we just add 360. So 360 plus 180 is 540. So we can therefore say that this next maximum occurs at 540. So this up here is 540 degrees. So now to find the value of t that this corresponds with, because that 540 is not the value of t, that's just the angle. So to find the value of t this corresponds with, we know that cos of 540 is -1. So therefore, 80t plus 16.70 must be equal to 540, because that's what's inside the brackets by cos. So if we just rearrange this and solve for t is equal to 540 minus 16.7 divided by 80. And if we put that into our calculator, we get 6.54, but that's 6.54 minutes. That and because time, there's only 60 seconds in a minute and not 100, 6.54 minutes doesn't mean 6 minutes and 54 seconds. So we have to do a side calculation, which is what is 0.54 of a minute. So if we were to do this, if we just did this to the side, 0.54 of a minute, where a minute is 60 seconds, we know that this is equal to 32 to two significant figures, because seconds can only go to two significant figures. So this means that 0.54 of a minute is 32 seconds. So we can say that the time is 6 minutes and 32 seconds. Now, the marks for this question, because there are 3 marks available, come from firstly setting 80t plus 16.7 to equal to 540. So that gets us our first method mark. And then we get a further method mark for rearranging this to find t, so get it in terms of t. And then finally we get an answer mark for saying that t is equal to 6 minutes and 32 seconds. So it's decided that to increase profits, the speed of the wheel is to be increased. And part D is asking, how would you adapt the equation of the model to reflect this increase in speed? So an increase in speed would mean that it travels the same distance, or it goes up or down the same height, but in a smaller period of time. If we think of it as the equation speed equals distance over time, for a speed to increase, time would decrease. And the way we would illustrate this on the graph is a kind of horizontal compression, or kind of the graph gets squashed. So if we were to draw it, it might look a bit like this, where there are kind of more maximums than there were before because it's been squished. And the way that we incorporate this compression in an equation is we increase the coefficient, it's called the number in front of, in this case the t value, So previously, the equation was h equals 11 minus root 109 cos 80t plus 16.70 degrees. And so the way we would then show this increase in speed in altering this equation is we increase the coefficient of t, it's called, and that is this number here, the 80. So we would increase the 80t value, and this could be to any number greater than 80, but we could do 90t, we could have 100t, any number greater than that would reflect an increase in speed. And the 1 mark for this question goes for stating that we need to increase the 80 in the formula, which we've done in this sentence here. And we've given an example which is also mentioned in the mark scheme.